In this presentation, we will identify the various states of matter that exist, and outline some of the properties that they exhibit. For several centuries, scientists have identified three main states of matter as solid, liquid and gas. However, in the last 100 years, scientists have discovered other states that are related to, or intermediate between these three main states. Later we will identify these other states. The first main state of matter is the solid state. Examples of the solid state are ice cubes and quartz crystals. The second main state of matter is the liquid state. Water and lava, which is liquid rock, are examples of the liquid state. The third main state of matter is the gas state. Steam from a pot of boiling water, and the helium in a balloon are examples of the gas state. Material in the solid state has a definite shape, and a definite volume. The particles, such as the atoms or molecules in a solid, are packed very closely together. The particles are locked in position, but they vibrate slowly, so they do not have enough energy to slide past each other, as shown in the diagram. Now let us look at some of the key properties of the solid state. The vibration of the particles increases when the solid is heated. This causes expansion of the solid. However, when the solid is cooled, the vibration of the particles decrease, causing the solid to contract in size. This can be demonstrated using a metal ball and a ring. Before the metal ball is heated, it fits easily through the ring. After heating with a hot flame, the metal ball expands, so it will not fit through the ring. A solid will change to the liquid state when it is heated to the temperature at which it melts, called the melting point. This is a characteristic property of a material because each solid has a unique melting point. A liquid has a definite volume, but unlike a solid, it has no shape of its own, so it takes the shape of its container. The volume of the liquid does not change, even if the shape of its container changes. This diagram shows that the blue liquid has the same 100 milliliter volume, whether it is contained in a graduated cylinder or a flask. The particles in a liquid are more loosely connected than they are in a solid. As shown in this diagram, the particles can collide with each other and move past each other. Another property of liquids is viscosity, which is a measure of the liquid's resistance to flowing. The unit of measure for viscosity is the centipoise. Honey is a liquid with a high viscosity of 2000 centipoises, while water has a low viscosity of 1 centipoise. Thus, honey has a viscosity that is 2000 times greater than that of water. Viscosity depends on the size and shape of its particles, as well as the attraction between the particles. Surface tension is another important property of water. It is the result of the water molecules being attracted closer together on the surface. It is because of surface tension that water forms droplets that can beat up on many surfaces. Rainwater droplets on the leaf of a tree is a good example. Surface tension is also responsible for an insect's ability to float on water. The closeness of the water molecules on the surface creates a kind of skin, to make a resting place for the insect. Gases are considered fluids like liquids. Unlike a liquid, a gas can easily change its volume with changes in temperature or pressure, as we will show later. The atoms and molecules in a gas are free to move independently. The particles in a gas collide with each other, and with the walls of the container frequently, as shown in this diagram. One of the key properties of a gas is that it changes its volume with a change in temperature. In the 1780s, Jacques Charles discovered the change in the volume of a gas with changes in temperature. Charles's law states that the volume of a gas increases with increasing temperature and decreased with decreasing temperature, at constant pressure. This means that the volume is directly proportional to temperature. The mathematical equation for Charles's law is that the volume V is equal to a constant K times the temperature T. This diagram shows how the volume of gas increases when the gas in the cylinder is heated with a flame. The second important property of a gas is that its volume changes with changes in pressure. This discovery was made in 1662 by Robert Boyle. Boyle's law states that at constant temperature, the volume of a gas decreases as the pressure increases. When the pressure of a gas decreases, its volume increases. Mathematically, the volume V is inversely proportional to the pressure P, so the equation is V equals a constant K, divided by the pressure P. This diagram shows the volume increase when the pressure is low, and the volume decrease when the pressure is high. The temperature is the same in both cases. In addition to the solid crystalline state of matter discussed previously, another solid state of matter is the amorphous state. Amorphous solids are sometimes called soft matter. Amorphous solids have atoms and molecules that are not arranged in a regular pattern. A key characteristic of amorphous solids is that they do not have defined melting points. Instead, they become softer and softer as they are heated. A good example of an amorphous solid is the butter that you might use on your toast. Other amorphous solids include plastics, rubber, and glass. There are other liquid states of matter that exist. One is the liquid crystalline state. Liquid crystals are truly intermediate between liquids and solids. The photo on the right shows a small bottle containing a liquid crystal. Although the material is a pure compound, the liquid has an opaque appearance. The molecules are arranged in a regular pattern like the solid state, but unlike the solid state, they can slide past each other as shown in this diagram. Liquid crystal molecules have long rod-like shapes. Ionic liquids are another unique state of matter. They are salts in the liquid state, which typically have melting points below 100 degrees Celsius. Ionic liquids are largely made of ions and short-lived ion pairs. The photo shows an ionic liquid in a small bottle. The colloid state is another liquid state of matter. Colloids are mixtures of microscopically dispersed particles of a substance in a liquid. A good example is milk, which is a colloid of fat particles suspended in water. There are two states of matter related to the gas state. Plasma is a state of matter in which an ionized gas becomes highly electrically conductive. It is typically generated by passing a high voltage of electricity through a gas as shown in the photo. The neon lamps used in bright lit signs use the gas plasma technology. Another case of a gas becoming another state of matter is the Bose-Einstein condensates. These condensates form when gases are cooled to temperatures close to absolute zero, which is also known as 0 Kelvin. Absolute zero is -273 degrees Celsius. These condensates are particles in the atoms of the gas, which are called bosons. This presentation was produced as a public service to help middle school and high school science teachers develop experiments and demonstrations that can be used in their classrooms. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.